Hello, Mr. Collier here. Today we're going to talk about Newton's third law, the rule of two. So Newton's third law is one of the most misunderstood concepts in science, and we're going to try to hash out any of those misconceptions today so that you have a pretty good understanding of how it works. Real quick recap, we've got Newton's first law says that an object at rest will continue to stay at rest or continue to travel at constant speed in a straight line unless compelled to change by forces acting on it. Also known as the law of inertia, this is just basically saying when the net force is equal to zero, then the acceleration is equal to zero. Law 2 says that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to the mass. Again, really just talking about what happens when forces are acting on an object. And in this case, when the net force is not zero, right? Zero in law 1 and not zero just says that the more you push on an object, the faster it will accelerate. Law 3 says when one object exerts a force on a second object, the second object exerts an equal and opposite force on the first. This is commonly explained as for every action there is an equal and opposite reaction. Another way to think about it is that forces always come in pairs. You're never going to have a single force. You might have a single force on an object, but not a single force total. The first force is equal but opposite to the second force. To kind of summarize, Law 1 explains what happens when all forces acting on an object are balanced. There's no acceleration. Law 2 explains that when the forces are not balanced, you do have acceleration, and it explains exactly how much acceleration there is. So all motion of any object is either Law 1, forces are balanced, or Law 2, forces are not balanced. However, all motion is Law 3. Law 3 is always true, forces always come in pairs. Law 1 and 2 deal with forces acting on a single object. So for example, we might look at what forces are acting on this rock right here that allows it to balance. What forces are acting on this car that allow it to accelerate. But Law 3 deals with forces acting between multiple objects. So now we're not just looking at this singular rock, we're saying how does this rock interact with this rock? Or how does this car interact with the road? And by looking at pairs of objects or multiple different forces at the same time, we start to have this deeper understanding of law number 3. So Newton's third law tells us that anytime two objects interact with each other, they exert equal and opposite forces on each other. However, the effect of those forces is not always the same. Sometimes there's motion in one object, but not the other. So for example, when a bullet fires out of a gun, the bullet pushes on the gun with the same force that the gun pushes on the bullet. However, because the bullet is such a small mass, that force accelerates the bullet greatly, whereas the force of the bullet on the gun has a much smaller effect, but there is recoil in the gun, which is that reaction force acting on the gun. And so for both objects, they have an equal force acting on them, but different mass, which causes different acceleration. Again, equal and opposite forces, but not necessarily equal and opposite motion from it. Here's a concept question from your homework that I think really gets to the heart of the misconceptions people have about Newton's third law. The farmer attaches a cart to a horse and asks that the horse pulls the cart. The horse says, I can't pull the cart because of Newton's third law. If I apply to the force to the cart will apply an equal and opposite force on me. So the net result will be that I can't pull the cart, the forces will cancel. Now, the problem with this reasoning is that it's not a full understanding of Newton's laws and forces. Let's take a deeper look. The way to analyze this is by looking at the different forces acting on the horse. So yes, the wagon exerts a force on the horse that is equal and opposite to the force of the horse on the wagon. However, the horse pulling the wagon is not what makes the horse move. The horse moves because the horse pushes against the ground, and the ground pushes against the horse, causing the horse to move. So when you look only at the forces acting on the horse, the force against the ground is greater than the force of the wagon pulling against the horse and so he can still move. So yes, forces come in pairs that are equal and opposite, but they do not act on the same object. The force on the horse, which is just fun to say, is what we care about for deciding whether or not the horse can move. Now we can actually start to do some math with this information. So say you have a 65 kilogram skater and a 55 kilogram skater. They're pushing against each other, and skater A accelerates at 2 meters per second squared. How fast will skater B accelerate? Well, we know that the forces acting on them are equal and opposite because they push against each other. So each skater has the same force acting on them, but since they have different masses, they'll accelerate differently. Force is equal to mass times acceleration. So the mass of skater A times the acceleration of skater A will be equal to the mass of skater B times the acceleration of skater B because, again, the forces acting on them are equal and opposite. So now I can plug in my numbers and I can multiply mass times acceleration, which would actually tell me the force acting on skater A, which I have all of that information, is equal to the force acting on skater B, which is the mass of that skater times that skater's acceleration. And I can solve for the acceleration on skater B. A little logic check, does my answer make sense? Well, skater A has less mass, so an equal force will make it accelerate more than skater B. Or another way to think about it, skater B is more massive, so an equal force won't accelerate it as much. So I should get a smaller acceleration. Another sort of conceptual thing here, how does a rocket fly? So a lot of people think of rocket flies because the gases push against the ground, but rockets will fly even when they're far off the ground. So the reality of it is it's the rocket pushing against the gases escaping from it, the gases escaping from it pushing against the rocket, and that is what makes a rocket fly. Action-reaction forces. And that's it for Newton's third law.